Hello, welcome back to our magic tutorials for chemistry. Today we shall discuss about the chemical properties of carboxylic acids. So we shall compare these properties with alcohols and phenols. So we know the general formula of alcohols, that is ROH, correct, where R it is the alkyl group. It can be methyl, ethyl, propyl, any alkyl group. When this alcohol it is treated with water, what happens is the OH bond breaks, it forms RO minus, correct, and hydronium ions, H3O plus ions. Now what is this RO minus? It is called as the alkoxide ion. It is called as alkoxide ion. Now what is the mechanism over here? How this bond is breaking O and H? Oxygen it is more electronegative than hydrogen. So it takes up the electron from this bond. So it gets a negative sign. Hydrogen gets a positive sign and this bond breaks. Okay. The next one, that is phenol. So onto the benzene ring, OH is attached. This is phenol. It is treated with water. Same way, what happens? OH bond breaks. So it forms the benzene ring with O minus and H3O plus ions. H3O plus ions, it is called as hydronium ions. Now what is this formed? It is phenoxide ion. Why it is called as a phenoxide ion? Because phenyl ring is present with oxygen attached to it, correct? So phenoxide ion. Now we are comparing the chemical properties of carboxylic acid with alcohols and phenols, correct? Why we are doing this? Because we know that alcohols and phenols, they are acidic in nature, correct? So in the previous videos I have uploaded about the chemical properties of alcohols and phenols. So if you check that, you will understand that alcohols and phenols are also acidic in nature, and that is the reason we are comparing this acidic nature with the acidic nature of carboxylic acids. Now alkoxide ion, it is RO minus here, right? RO minus, oxygen having a negative sign. This alkoxide ion, it is having a R group. I already told R is what? Alkyl group, correct? It can be methyl, ethyl, propyl. So what are these alkyl groups? They are EDG. That means they are electron donating groups, correct? They will donate electrons. So when they donate electrons, what happens? When the alkyl groups, they are donating, giving electrons, what will happen? Moreover, you can see here oxygen, it is more electronegative than carbon, correct? R stands for the carbon, the alkyl group. Oxygen is more electronegative, so it will accept the electrons given by that carbon. And moreover, R, it is the electron donating group. So what happens? Electron density on oxygen increases. Electron density on oxygen will increase. Now, if the electron density on oxygen increases, that means it can easily accept a proton, H plus ion, right? So what it will do? It will accept a proton very easily. H plus ion, it is also called as proton. So electrons, they are given, they are donated by this R group, which is taken up by oxygen. So the electron density increases. So easily, if electrons are available, it can accept a proton, negative and positive attraction, right? Now what do you mean by this word acidic? Correct? We know the term acidic, that means it is an acid compound. What is the general definition? So far we have learnt for acid, which accepts or gives, that is which will donate, correct? Which will donate H plus ions, correct? So acids are which donate H plus ions. Now over here what is happening? As the electron density on oxygen increases, it is accepting a proton. instead of giving a proton, it is accepting a proton. Correct? That is the reason alcohols, they are less acidic. Correct? Here we are comparing the chemical properties, that is the acidic properties of alcohol, phenols as well as carboxylic acid. Right? So, alcohols, they are less acidic. Moreover, this alkoxide ion, it is unstable also. Correct? So, leave this one, the first one. Come to the next one, that is phenols. When it is treated with water, it will form phenoxide ion and hydronium ion. Now, this phenoxide ion, it is having electrons. The oxygen attached, it is having electrons. What it will do? It will undergo resonance. Right? It will undergo resonance. Now, when it undergoes resonance, the phenoxide ion, when it undergoes resonance, the carbon present, correct, in the benzene ring, it gets negative sign. We know that during resonance, the electrons will be coming at what positions? Ortho and para positions. Correct? The electrons are shifted to ortho and para positions. So, here the carbon of the benzene ring gets a negative sign. Carbon gets a negative sign. Right? So, if we compare the stability over here, alkoxide ion, it is unstable, but phenoxide ion, it is stable because this is undergoing resonance. Just make a note of it so that I can move to the next and explain you about the acid's acidic nature. The chemical properties, that is the acidic nature of carboxylic acids. Correct? We already saw the stability and instability of alkoxide ion and phenoxide ion. Okay. Now, for the acids, so the general formula I have written over here, RCOOH. When it is treated with water, correct, what it will form? Again the OH bond is breaking. So, it forms RCOO minus plus H3O plus ions. Again hydronium ions are formed and carboxylate ion is formed. Carboxylate ion is formed. Okay. This carboxylate ion, it undergoes resonance. So, check for the resonating structures. RC, single bond oxygen, double bond oxygen, oxygen having a negative sign. Correct? This is a structure for carboxylate ion. Now, if we draw the resonating structures over here, this electron, it will go to the bond and the bond will shift as electrons onto oxygen. So, the second resonating structure over here will be single bond oxygen having a negative sign. Here oxygen attached to carbon with a double bond. Correct? So, these two are the resonating structures of carboxylate ion. So, together if we want to draw, we can draw the hybrid resonating structure. Hybrid resonating structure, it can be drawn as R, C, single bond O, correct, with oxygen having a negative sign and the electrons are shifting in this position. Right? So, this is called as the hybrid resonating structure. Okay. So, compare the resonating structures of phenols as well as for carboxylic acid, that is for carboxylate ion. So, if we take the resonating structures of phenoxide ion, correct, we will get the electrons on ortho and para positions, right. I am not drawing all the structures for resonating, but just understand that during resonance there will be a double bond between the carbon and oxygen, right, and this electron will be shifting, right, delocalization of electrons. So, carbon gets a negative sign. In phenoxide ion, in the resonating structures, carbon gets a negative sign. But if you check over here, in carboxylate ion, oxygen is getting a negative sign. Oxygen is getting a negative sign, right? So now which is more stable? Check. Carbon and oxygen, which is more electronegative? Oxygen. So oxygen should only get the negative sign. But if you check in the phenoxide ion, in the resonating structures, carbon is getting a negative sign, right? So which is more stable over here? Carboxylate ion is the most stable, correct? So we have known about the stability, that carboxylate ion, it is more stable than phenoxide ion, correct, than alkoxide ion. So the order for acidity, that is carboxylic acids, their acidity is the greatest, correct, their acidic nature is more compared to phenols as compared to alcohols also. So this is the order. So if in the exam, if any three compounds are given, one acidic compound, phenol, and one alcohol compound, it is asked to arrange these compounds in their acidic order, correct? So you will first arrange any acidic compound, then phenol, and then any alcohol compound. So this is the order for acidity, and all this order we have found based on how they undergo and form the ions when it is treated with water. So let's discuss about the pKa values and the Ka values, correct? The Ka values and pKa values, and how it affects the acidity, right? So we'll take the same example, acidic compound, it is treated with water, it will form carboxylate ions and hydronium ions, right? Now if we want to write the equilibrium constant for this equation, Keq, that is equilibrium, K stands for the word constant. We write it as the concentration of the products, right, divided by the concentration of the reactant. Remember, water has no effect on diluting, or if you add more water also it has no effect, right? Less water also no effect. So the concentration of water will not affect the equilibrium process. So over here water is taken, right? Water is taken. So if I take this water concentration onto the left hand side, then we can write the expression as Ka. Now what is Ka? It is acid dissociation constant. Taking water to left hand side, we are just substituting the K equilibrium as Ka, that is acid dissociation constant, correct? So Ka is equal to RCOO minus H3O plus ions upon RCOOH, correct? Now acid means what? H plus ion concentration will be higher, right? Or H3O plus concentration, this ion concentration, if it is greater means it is acidic in nature. Okay. From this equation, if the concentration of H3O plus ion is increased, what will happen to Ka value? Ka value will also increase, right? Ka value will also increase. Okay. If Ka value increases, we can also write it as the acidic nature also increases, right? Now let's check for the pK values. We know the expression we write for H, that is pH is equal to minus log of H plus ions, right? So if I write for the acid constant pKa, how can I write? Just change the expression, log of Ka, correct? Okay. Now from this second equation, if Ka is increased, this concentration, acid dissociation constant value, it is increased, what will happen to pKa value? It will decrease because there is a minus sign. So, pKa value decreases. Correct. So, this we are learning from the equilibrium chapter. We are writing the expression according to that chapter, and we understand that if the concentration of H3O plus ions increases, the Ka value increases, acidic nature increases, but the value of pKa will be less. It decreases. Let's see now. I told you about the carboxylate ion. Correct, carboxylate ion, that is RCOO minus. Correct. Now into this, if the R group it is substituted by any EWG, correct, or if the R group is substituted by any EDG, right. So what is EWG? It is electron withdrawing group. Correct, electron withdrawing group. What is EDG? It is electron donating group. Check the difference. One is electron withdrawing group, one is electron donating group. Now, withdrawing group means what? This group, what is attached over here, it is taking up the electrons. Correct, it is taking up the electrons. Now, if it is taking up the electrons, then the electron density on oxygen will decrease. Correct, electron density on oxygen will decrease, right. If there is less negative charge on oxygen, then it cannot accept H plus ions, right. Negative sign is not there, so how can it accept a positive proton? Correct. So, if there is an electron withdrawing group, the electron density on oxygen will decrease. So, H plus ions it cannot accept, right. Okay. Come to the next one, EDG, electron donating groups. This previously also in alkoxide ion I told you. So, if it is donating electrons, what will happen? The electron density on oxygen will increase. Correct, the electron density on oxygen increases. Now H plus, it is positive. Correct, so negative and positive attraction will be there. So easily it will accept a proton. So see the difference here. If electron withdrawing group is present, it cannot accept a proton. Correct, the COO minus, that oxygen, cannot accept a proton. But if EDG is present, it can accept a proton. Now what is a simple definition of acids? The species which can donate a proton. Correct, donation. It will donate a proton. So which is donating a proton here? This one. It is not accepting. But over here it is accepting. Here it is not accepting. Here it is accepting. Correct. So what I am telling is, if EWG group is attached, that means acidic nature increases. Acidic nature increases. If EDG is present, means acidic nature decreases. So this is the difference between both the groups. So let's check some reactions of carboxylic acids. The first one, that is esterification reaction. Correct, formation of ester. Esterification, that is formation of ester compound. Acids, I will write the general formula. R group you can substitute. So acids, when it is treated with an alcohol compound in the presence of an acid, correct, what it will form? It will form ester. Now how is this mechanism? Hydrogen will be given by the acid. We know acids will donate hydrogen. Alcohols, it is giving OH. So what is removed over here? Water. What is left over here? R. Write down this as COO and this R dash. Why I have written it as R dash? Because this R and this R, it can be same, it can be different also. Correct? It all depends on how you substitute the alkyl groups or the aryl ring over here. Right? So it can be same, it can be different also. So the first reaction, that is esterification, formation of an ester compound, where acid it is treated with alcohol and a molecule of water is removed. The second reaction, it is with the phosphorus trichloride. So again RCOH, I am just writing in the structure to explain it, plus PCl3, correct, phosphorus trichloride, 3 chlorine are there, so it is trichloride. So what is removed over here? Just check it. RCOCl, this group RCO, correct, OH it is removed, RCO it attaches with this chlorine. So that is RCOCl. What is left here now? OH and P, correct. So the byproduct is H3PO3. So what is this general compound? Generally I have written it. It is called as acid chloride compound. Acid chloride compound. And this H3PO3, it is phosphorus acid. It is phosphorus acid. Let's check the next reaction. The next reaction with PCl5. With the PCl5, so we are taking an acidic compound. Into that we are adding PCl5. Correct. Again what will happen? The bond of C and O will break. C to O bond is breaking. Cl will attach, so it becomes RC double bond O Cl. Correct. Plus what is left now? POH and 1 Cl. Two byproducts are formed. One is POCl3 and HCl. Correct. Again acid chloride is the compound. POCl3, the name is phosphoryl chloride. Phosphoryl chloride, and hydrochloric acid is the byproduct. Check for one more reaction here. One more reaction, that is for acids. It is treated with SOCl2, that is thionyl chloride, right. What it will give? Again the C to O bond will break. It will form RC double bond O Cl plus, correct. So what is left over here is SO2 and HCl. This SO2 and HCl, they are escapable gases, correct, escapable gases. So now just check this. First one is the esterification process, right, and the last three, what I have written with the PCl3, one with PCl5 and one with SOCl2, correct. All the three, the same set of reactions we have also done it in the first chapter, that is haloalkanes and haloarenes chapter. That is a preparation of halo compounds, correct. So if you go to the previous videos, you can understand. Go to that halo chapter videos and just check for these reactions. The reaction is the same. The byproducts what I have written here, that is also the same. If you remember in the alcohol, that halo chapter, here we are taking alcohols, right, where this process it was called as a Darzon's process. It's a name reaction, correct, but here we are treating it with SOCl2, it is treated with acidic compound. So make a note of these reactions. So let's check with the next reaction, that is CH3COOH when treated with ammonia, correct. So the next reaction, it is acid when it is treated with ammonia, what is the product formed? Okay, so first when acid, here I have taken an example, that is ethanoic acid, 2 carbons are there, it is ethanoic acid. The common name it is acetic acid. It is treated with NH3 ammonia. What will happen is, it will combine and it will form CH3, COO minus and NH4 plus. Correct? Hydrogen, this oxygen to hydrogen bond breaks. It will be taken by this nitrogen. Correct? Lone pair of nitrogen. Because oxygen, it will take up the electrons from this bond, it will become negative. Hydrogen having a positive sign, it will attach with N, nitrogen. Right? From here, it is heated. So while heating, what happens? A molecule of water is removed. Correct? A molecule of water is removed. So we are removing the molecule of water from here, that is H4 is there, 2 hydrogen from here and 1 oxygen from here. So what is the compound we are getting is CH3, CO, NH2. If you write the structure for this, it is CH3, correct, C double bond O and NH2, right. So what is this RCONH2 group? It is amide compound. It is amide compound. As there are 2 carbons, the name of this compound, it is ethanamide. Ethanamide. Correct. You can check that the number of carbon atoms in the reactant and in the product remains the same. The next reaction, let's check it. When 2 units of acetic acid combines, or any acid when it is combining, what happens? So I'll take the example of acetic acid again. I'll draw the structure for that. That is CH3, C double bond O and OH. Correct? 2 units. So again onto this side I will draw the second unit, that is CH3, carbon, right, double bond O, over here O and H. So 2 units of acetic acid, that is ethanoic acid I have taken here. Correct? So 2 units, it is treated with sulfuric acid or P2O5, that is phosphorus pentoxide. Heating is done. Correct? Now we know this. What is H2SO4? It is a dehydrating agent. Correct? Dehydrating means what? A molecule of water will be removed. So how the molecule of water will be removed? From here, H2O. Correct? You can take this OH and this H also. So a molecule of water is removed, which becomes the byproduct. Now what is left over here? That we will write CH3. Correct? Carbon with the double bond O. Onto this side, it is attached with this oxygen, correct, which is further attached with 1 carbon having a double bond O and CH3. So what is this compound now? I can also write it as CH3 CO whole twice O, correct, twice O. So what is this compound? It is anhydride compound. As there are 2 carbons over here, correct, what we are taking here? Acetic acid, right. So the name, it is acetic anhydride. Name of the product is acetic anhydride. So from acids, acetic anhydride can be formed. Decarboxylation, that means what? D word is there, correct. Carboxylation means CO2 gas is released. Correct, removal of CO2. Okay, so here we are taking with salt of carboxylic acid, correct, salt of sodium, salt of acetic acid, correct, because it is salt of carboxylic. This acid, it is obtained, the salt, it is obtained from the acid. When it is treated with NaOH, in the presence of CaO, calcium oxide, correct. Now this mixture NaOH and CaO, the mixture name, it is soda lime. Heating is done. So what will happen here is this NaONa, it is removed along with the COONa, right. So what is left here? You can see CH3 and 1 H. I can write it as CH4. Byproduct will be Na2CO3. Just rearrange and write as Na2CO3. So what is formed here? Methane compound, which is an alkane compound. So we can also form alkanes, hydrocarbons from carboxylic acid salt. The next one, it's a name reaction, correct? The name, it is Hell-Volhard-Zelinsky reaction, correct? We also name it as HVZ reaction, HVZ reaction. What happens here is halogenation of the acids. Halogenation means what? Addition of halogens to acids. Correct? We are adding halogens to acids. We will just take an example over here. RCH2COOH. I have taken an acidic compound over here. Now you will be thinking why I took like this, right? Instead of writing RCOOH directly, I have also attached one carbon in between. Okay, I will tell you. We are taking this acid because it's a name reaction, and in this reaction alpha hydrogen is must. There should be a presence of alpha hydrogen, correct? That means you have to remove this alpha hydrogen and you have to attach halogen. This is what happens in this reaction. Removal of alpha hydrogen and halogen, it is attached. So what is needed here? Alpha hydrogen. Now how to identify this alpha hydrogen? So acidic group, the functional group is here, right? So the carbon which is attached to that functional group, that becomes the alpha carbon, and the hydrogens attached will become alpha hydrogen, right? Now this reaction, it happens in the presence of red phosphorus, right? Red phosphorus. Halogen is attached, and the halogen, it can be chlorine, it can be bromine, Cl or Br. It can be Cl2, it can be Br2, chlorine or bromine. Red phosphorus, it is taken in less quantity, correct? Red phosphorus, it is taken in very less quantity. Less quantity it is taken, and the halogen, it can be chlorine or bromine. So what is formed here? As I told you, alpha hydrogen, you have to remove it, right? In place of that, you will attach one halogen. So general formula, I will just write C, H is already here. Here I have attached one halogen, COOH as it is. So what is the name of this compound? The general name, that is alpha halocarboxylic acid. Correct. So if you are attaching chlorine in place of this X, suppose the halogen you have taken here is chlorine, then it will be alpha chloro carboxylic acid. If you are taking bromine, it will be alpha bromo carboxylic acid. Also the reaction takes place in the presence of water. So this is a name reaction where alpha hydrogen is must. Just in place of alpha hydrogen, you will be substituting one halogen, and the halogen will be chlorine or bromine. The last set of reactions, that is electrophilic substitution reactions. Electrophilic substitution reactions. In most of the organic chapters, we are learning this set of reactions. If you remember, nitration, halogenation, correct? Then sulfonation, Friedel-Crafts, right? So here we will learn only one or two reactions. Let's check that. So electrophilic substitution reactions in benzoic acid, correct? I have taken the benzene ring here attached to the group COOH, so it is benzoic acid, right? Benzoic acid. It is treated with H2SO4 and HNO3, sulfuric acid and nitric acid. So what it will form? It will form COOH as it is. nitro group will attach, correct. So what is the electrophile over here? It is NO2 plus. It is attaching to the ring. It is called as what? Nitronium ion. Nitronium ion. That is the electrophile here which is attaching to the ring, correct. And they all are, it will be attaching to the meta position. Why meta position? Because this group, that is COOH group, the acidic group, it is meta directing group. It is meta directing group, correct. Okay. The second reaction, it will be treated with Br2 in the presence of FeBr3. Bromination in the presence of FeBr3. Again what happens? Onto the benzene ring, the acid group is present and Br will attach to the ring, correct. Again I am saying this acidic group, it is meta directing group. So the product formed here, that means the substituent which gets attached, it gets attached to the meta position. It gets attached to the meta position. So this acidic group, that is COOH, it is meta directing group which deactivates the ring. Why it is deactivating? Because it will pull the electrons, correct. During resonance what happens actually? From the group the electrons will be delocalized onto the benzene rings carbon. But here COOH group, it deactivates the ring by pulling the electrons, because oxygen, 2 oxygen are there which is more electronegative. So these are the compounds formed. The next one, benzoic acid. We are learning the set of reactions here, but benzoic acid will not give Friedel-Crafts reaction, correct. Friedel-Crafts reaction, we have two set of reactions. One is acylation, one is alkylation. So benzoic acid does not form the products if Friedel-Crafts reagents are used. So what is the reason is, this COOH group, it is electron withdrawing group. I told you now, right? During resonance what will happen? It will pull the electrons because it is withdrawing the electrons from the group. It is an electron withdrawing group. So it will pull the electrons from the ring towards itself, correct. Now during Friedel-Crafts reaction we are using AlCl3, anhydrous AlCl3, which act as a Lewis acid, right. So this AlCl3, when it is treated with CH3Cl, here I am talking of Friedel-Crafts reaction with, that is alkylation, right. So alkyl group I have taken. So when these two are reacting, what it will form? It will form CH3 plus. At the same time AlCl4 minus, correct. So what is the electrophile present here? CH3 plus. So CH3 plus, it is positive, correct. It is positive in nature. Now positive in nature means, now think, this is electron withdrawing group. Understand, the COOH, it is electron withdrawing group. It is taking the electrons during resonance. If it is taking the electrons, there is no negative sign for the carbon present over here in the benzene ring, correct. Every time during resonance what happens is, the carbon of the ring will get the negative sign, correct. But here COOH, it is withdrawing the electrons. It is taking the electrons towards itself. So the carbon present here is not getting the negative sign. If it is not getting the negative sign, how can it accept this positive CH3 plus? Negative to positive attraction won't happen, right. So instead of that, no substitution happens on the ring. What is the reason is, because COOH, it is electron withdrawing group, correct? No substitution happens because it is electron withdrawing group which will take up the electrons, correct? So that is the reason benzoic acid will not undergo Friedel-Crafts reaction. So here we complete with the chemical properties of carboxylic acids. In the next class we will be doing with the topics of aldehydes and ketones. Thank you. Keep watching.